We will be talking about lines in space, equation of a line in space, equation of a plane in space, and the angle between the two planes. Those are 3 examples which I would like to go over with you. Example 1, people, if you're not talking, it will just make my life easier, your life easier. I'll finish faster, and you don't have to suffer that much. Example 1, write a symmetric equation. Just write it down for now. I'll explain what it is. Write a symmetric, I will explain this word in a minute. Write a symmetric equation of a line that passes through 2 points. That passes through point P minus 2, 1, 0, and point Q, which has the following coordinates 1, 3, and 5. Please write this down. Write a symmetric equation of a line that passes through point P and Q. I will just show you how this works. The equation of a line, this will be given on the test. You don't have to memorize that. So the equation of a line will look the following way. X minus x1 over A equal y minus y1 over B. Write it down, I'll tell you what each letter is. Z minus z1 over C. And again, this equation will be given to you. Nothing has to be memorized. In this beautiful equation, x1, y1, and z1 will be coordinates of any point which belongs to this line. And you can choose P or Q, doesn't matter. Let it be P, x1, y1, z1. And A, B, and C will be components of vector PQ. Let me extend this a bit. A, B, C will be components of vector PQ. So what we have to do, we have to find PQ. There's three numbers, which will be A, B, and C. And x1, y1, z1 already given to us at any point which belongs to this line. Let's do P, for example. All right, so let's start with finding PQ. We have point P, we have point Q. To find the vector PQ, as you know, it's terminal minus initial. Terminal Q minus P. 1 plus 2, comma 3 minus 1, comma 5 minus 0, equal 3, 2, 5. All I did is I subtracted terminal minus initial, and I claimed those are the coordinates of A, B, and C. A, B, and C. And at this point, I'm ready to write an equation. I have A, B, C. I have x1, y1, z1. Plug it in, and you're done. And example 1 will be over. So you guys have the equation in front of you. X minus, what is x1? It's coordinate of P. Wait. Let me just write this down on the side. P has coordinates minus 2, 1, 0, and vector PQ has components of 3, 2, 5. And we said that 3, 2, 5 are ABC. A, B, C, and we said this is x1, y1, z1. Okay, now I'm plugging it in. X plus, by formula, it's x minus x1, so x plus 2 over A over 3 equal y minus 1 over 2 equals z minus 0 over 5. Okay, that's it. That's the first example, and it's over. First example is done. That's the answer. That's all you have to do. Don't simplify anything. That's all I want for full credit on the test. Example 2. So at this point, we are 33% done. Example 2. Wait. Yeah, sure. Thank you. Example 2, find equation describing the plane. Find equation describing the plane. The plane through point P, that P belongs to the plane. The coordinates are 3, 2, 1. And perpendicular to the vector 5, 2, minus 1. Find equation describing the plane through point P, which belongs to the plane 3, 2, 1, and perpendicular to vector V 5, 2, minus 1. Yes. Yes. Solution and the formula will be given to you on the test as well. This is the formula of the equation of the plane. A x minus x1 plus b y minus y1 plus c z minus z1 equal to 0. What do you think is A, B, and C? What are those? Yeah, but out of what I have, what could A, B, and C be? Would it be a point or a vector? Vector. Yes, A, B, and C are components of the vector. This is A, this is B, and this is C. Those are the components of the vector. And x1, y1, and z1 are points of any point on the plane. I only have one. So this stuff is this. So all you have to do now, plug in the numbers and you're done. Again, the formula will be given to you. There is really nothing to memorize at this point. Formula will be given, plug in the numbers, and don't distribute anything, leave it the way it is. 5x minus what? 3 plus what? Y minus 2 minus 1, z minus 1. And stop there. There's nothing else you have to do. You don't have to distribute. It's a standard form of an equation. That's enough for full credit on the test. We are 66.6% done. We have one more example. One more example. No, thank you. Angle between the planes. That's the last one, called angle between the planes. Between the planes. And here I'll draw a quick picture. You don't have to draw it if you don't want to. The angle between the planes. Imagine there are two planes in space. I'll do my best drawing picture. There's one plane. And maybe this will be another plane. How would I draw it? This is last problem, yes. Imagine there are two planes. Two planes in space. The angle between the two planes in space, let's call it angle theta, is the angle between two normal vectors. Do you know what normal vector is? It's perpendicular. Normal, orthogonal, perpendicular, they're all synonyms. So theta is the same as normal vector to both planes. So this theta and this theta will be the same. You don't have to memorize it if you don't want to. I'll show the example. But this is just the definition how to find the angle between the planes. I said that the angle between the planes is the same as the angle between the two vectors, let's call it n1 and n2, which are perpendicular, or they call normal vectors. And now we'll show you, and the formula, maybe the formula is already known to you. Maybe you remember this. Anyone knows? Formula between the two vectors? Yes, we know at least something familiar. At least this is dot product, and this is multiplication. Let's also put absolute value, just to eliminate any of the minuses. I'll show you one example, and we are done with this. Example, find the angle between the two planes described by two equations. Plane 1 has equation 5x minus 2y plus 3z equals 0. And the other one is minus 2x plus 1y plus 1z equal to 0. I wrote the equation of two planes. Now I want to find the angle between them. N1. Thank you for noticing this. This should be N1. No, you can't solve it. No. You have to find normal vector to one plane. You have to find normal vector to the other plane and then follow this formula. But finding normal vector is pretty simple. Find N1. Let me just try to guess how to find it. What are the numbers for N1? That's it. And what are the normal vector 2? Okay. And from there, you already know what to do. From there, you just plug it in the formula. We'll do the dot product of N1 and N2 on the top, and we will do the magnitude of N1 times magnitude of N2. Cosine theta is, we'll start with the dot product. 5 times minus 2, negative 10, plus minus 2 times 1, minus 2 times 1, plus 3 times 1. On the bottom, magnitude of N1 is 5 squared plus 2 squared plus 3 squared, square root, times magnitude of 4 plus 1 plus 1. And if you can please tell me what is theta. Maybe I can just scroll down and tell me what is theta. Just put it in a calculator. Arc cosine, of course. Inverse cosine of whatever numbers you get here. What's in the bottom? Multiply, yeah, not cross, no. Let it be. Thank you very much. And we are done with the notes. Did you do the absolute value on the top? Did you do positive on the top? Yes? Okay, let it be 126.5. And this is over